Hello everyone, we've got this AQA paper, Foundation Tier, Paper 2 Calculator, and it's from Monday the 3rd of June 2024. Just a quick message before we start. I've written a book to help with your studies. It's not a textbook. The book is based on the psychology of learning, insights gained from years of working one-to-one with students. It's full of practical methods to help you understand, remember and apply mathematics. The book's available on Amazon and the link is in the description below. Now let's get on with the paper. I like to use a calculator, so we'll make good use of that. Write 0.27 as a fraction. Now I can see it's 27 over 100, but I'll show you we can use the calculator for that. And as usual, it's 1 mark, so we don't need to show any working. So we're going to use the calculator, and if I put in 0.27 go equals, we get straight away 27 over 100. We can use the calculator to do this for us. Similarly, we've got write 2/5 as a decimal. Well, that is going to be 0.4 because 1/5 is 0.2. But again, we can use this. Let me just clear this. This time we put the fraction in. 2 over 5 go equals, and then this time we SD and we get 0.4. 0.35 is a percentage. Well, percent means out of 100. So it really means 35%, because it really means 35 100ths. And this is the 100ths column there on the 5. Simplify fully, x plus 4x. Well, x is just something, and it'll have the same value there. So we've got 4 of them there, 1 of them there, we've got 5 x's. This time we've got simplified fully, it says we've got 5 times 2w. Well, 2w is the thing, we've got 5 of them, there's 2 of them there, so 5 2's, 10w. Simplify fully, 2m divided by m. Well, I'm going to write that as 2m over m, which is what divide is. And we can just cancel them like that. So our answer is 2. And you can think of it like this: 2 times 5 is 10. Just putting 5 in as an example, over 5. 5 representing the m. 2 5s are 10, and then 5s into 10 is 2. So that's why we can do this sort of cancelling. Any number times itself is squared. So y times y is y squared. And we do it again, times y, we get y cubed. Here is a quadrilateral. Write down the letter of the obtuse angle. An obtuse angle is one that's greater than 90 degrees, but less than 180. So that one, these are both less than 90. There's a 90. This is our obtuse angle, C. And then the next, I can see the next one is write down the letter of an acute angle. It's A or D. So I'll put A down, I think. How many lines of symmetry does the shape have? Well, I don't think there's any. There's no way I can put a line through this where it's the same shape one side of the line and the other, because we don't know what these angles are. So I'm going to put 0. 1 lettuce costs £1.29. How much do 7 of these lettuces cost? We can use the calculator. So it's 1.29 times 7. And we're going to put our answer down here. I don't really even need to show this piece because it's only 1 mark. They just want the answer. Now we've got 903 over 100. So SD it 9.03. 5 cucumbers cost £6.40 in total. How much do 2 of these cucumbers cost? Well, we've got £6.40. If we divide by 5, we're going to get the cost of 1 cucumber, that bit, and then times it by 2. So I can do that in the calculator as well. £2.56. Question 5. Company sells 3 types of bottles. The pictogram shows how many bottles they sold 1 week. The key is this. That key represents 20 bottles. So each one of these is 5. Each little square is 5. There's our plastic, there's our glass, and here's our steel. The company sold more plastic bottles than glass bottles that week. How many more? Well, it's 2 marks, so they want to see some working. We've got 20, 40, 60, 80, 100. This is 100 here. That's the plastic. If we take away the number of glass bottles, we're going to end up with our value. So this is 20, 40, minus 40. 100, take away 40 is 60. So it's 2 marks. So we've shown some working and we've given the answer. And to put it there, better put it in the right place. The company sells each still bottle for £17.50. Work out the total amount of money made from selling still bottles that week. Well, taken will be rather than made, but there we go. Let's not complicate it. 20, 40, 60, 80, 100, 120, 125. So I'm going to put 125 up there. They can see it. I'll move this line down here. Nothing wrong with putting lines on. In the exam, it will help the examiner. So it's 125. Each bottle makes £17.50. So times £17.50. Okay, and we can use the calculator. Let's do it again. 2187, and make it 50 on the end like that, rather than just the 5, because it's pence, 50 pence. Shape A, B, C, D, E is drawn on the centimetre grid, and I like to do this. A to B is there, C, D, E, okay. Complete this statement. A to B is in the ratio of 5 to 1. That means equals 5 to 1. So we've got 1, 1, 2, 3, 4, 5. So if that's 5, we've got to find something which is 1. If it was 10, we'd have to find something which was 2. That's the only one that's 1. So it's A to B is this, A to B to D to C is in the ratio of 5 to 1. And then the next question here is, on this centimetre grid, that must be below, draw a rectangle with the same area as shape A, B, C, D, E. Right, so we need, first of all, the same area. So we've got here, the complete squares are, we've got here, this lot here. Look at the complete ones first. That's 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 squares in there. We've got a half here, a half there. So I'm going to put a half. This is a half, half, and a half there because they're cut down the diagonals. So we've got an extra 1 there and another 1 there. So the total equals 10. That's our total. You don't have to put all this in really, but there we go. So the total is 10. We've got to make another grid, which has got 10. I think we go 5 by 2. There's our 5. Actually, 5/2 is the only one we can do. Either this way up or vertical. Okay. Yeah, same area. Question 7, use a ruler for this question. Here is an accurate drawing of an equilateral triangle. By measuring, work out the perimeter of the triangle. Just take the units of your answer. Okay. Measuring on an A4 sheet, one side, 74 millimeters. Okay, we've got 3 sides. It's equilateral. They're all going to be 74. So our answer is perimeter we're doing all the way around. The way I like to think of a perimeter, go up there all the way up one side to that point, down to this one, and then back. And how far have we travelled? 74 times 3. 222. And we've got to show our units as well. 222 millimeters. And also, they want to see some working. 74 times 3. Question 8. There are 56 cubes in a box. Cubes are green, red, blue, or white. 17 cubes are green. There's an equal number of red, blue, and white cubes. And we've got to find out how many red ones there are. Okay. So, right. If 56 cubes are in the box and 17 cubes are green, the rest of them must be this lot. So let's take the 17 off of the 56. Minus 17. 7 off of 16 is 9. 1 off of 4 is 3. 39. Okay, so we've got 39 of them. And they're split between red, blue, and white, which are all the same number. So we can divide by 3, which gives us 13, which I'll put down there. Okay, that's that. Of course, you can use the calculator. 24 more cubes are added to the box. Cube is picked at random. Probably at the cube is green is 0.4. How many of the 24 cubes added to the box are green? Okay, so we've now got to look at the total again. We had 56 cubes, we're adding 24. So let's do that first. 56 plus 20. Sorry about my voice, I'm getting a bit croaky. But so carry the 1 over. 5, 6, 7, 8. So we've got 80 now. 80. And we know the probability of green is 0.4. So if we times it by 0.4, we will now know how many green cubes there are. So 4 8s are 32. So it's going to be 32. And originally we had how many? 17. So if we take 32 minus the 17, I'm going to use the calculator just to show that we can use it. 32 minus 17. 15. Our answer is 15. So an extra 15 green cubes were added to the box. That's that one. An electric car uses 1 unit of electricity to travel 3 miles. 1 unit of electricity costs 50 pence. Okay. Work out the cost of electricity in pounds to travel 270 miles. I think the best way to do this is, right, we got the 270 miles. And it costs 50 pence to go 3 miles. So if we divide it by the 3, it's finding how many 3 miles there are in the 270. Well, 3 goes into 27 9 times, so it's 90. And then our answer is going to be 90 times, we've got to put the answer in pounds, 0.50. Yes, because it's 90 lots of 3 miles. And Well, I can see that's going to be £45. But why do you use the calculator? No problem. Lima buys 2 meters of linen at £8.50 per meter. She also buys 5 meters of cotton. The total cost is £38. What is the cost of 1 meter of cotton? Okay. Well, she's bought the linen and bought 2 of them, £8.50 per meter. Let's work out the amount of linen bought, or the cost of the linen. So that's going to be £8.50 times 2. This is how we get our first marks, 4 marks. So let's do this one first. You can use the calculator, but 2 8s are 16, and we're going to have to add another one on. That's going to be £17. Okay, that's the linen. The total cost, she buys 5 meters of cotton. The total cost is 38. So let's take the cost of the linen off of this, and we're going to find out how much was spent on cotton. So that's 38 minus the 17. 7 from 8 is 1. 1 from 3 is 2. 21. Okay. £21. So that's that. That's cotton cost. The question is, what is the cost of 1 meter? But she bought 5 meters. So this £21 represents 5 meters. So now we go £21. We can put the zeros down if we want and divide by 5. And that will give us the cost of 1 meter. So 1 mark for that, 1 mark for this bit, another mark for this, and then our answer gives us the 4th mark. Okay, I'm going to do it this way. 21 divide by 5 shows it as a fraction. SD it, £4.2. Yes, £4.20. Do show the extra 0 because it's an actual costing of money. Buttons cost 65 pence each. The greatest number of buttons Lima can buy with £5 is 7. Okay. She says the greatest number of buttons I can buy with £10 is 14 because 10 is double 5. Well, it depends. I think we need to do the calculation. And the way we're going to do that is we're going to go £10. Now, make it all into pence. £10 equals 1,000 pence. Okay, £10 equals 1,000 pence. And then we can go 1,000 divided by 65. We're using pence, so this is pence each time. So, and then we can use the calculator. Divide by 65. Let's do it. It's 15. 15.3. Oh, we're going to cross that bit out because you can't have 0.3 of a button, but she can buy 15 buttons. The £5 bought her 7 buttons and there was a bit left over. And the bit left over on the other £5 enables the extra 1 button to be bought. Is she correct? No, she isn't. And there's our reason, 15 buttons. Here's a table of values for the equation y equals 3x plus 1. Draw the graph of y equals 3x plus 1 for values of x from 1 to 4. So there we go, from 1 to 4. Okay, and we just have to plot them. So we go, I like to always be very methodical. Right, x, 1, up 4. There we go. Now, next one is along 2, up 7. Just there. Of course, it's going to be a straight line. So next one is 310. And the next one is 413. Just in there. Okay. And we've got to draw the graph and they only want it between those points, so we do them between those points. Work out the value of y when x equals 2.5. Well, we look at 2.5. It says work out rather than calculate. 2.5 is here. No, not 9. It's going to be probably 8.5 or something. We'll find out. We can use the calculator. You're allowed to use the calculator, so use it. 3 times 2.5 and put in the value of x in to the equation, and then I'm adding the 1 on like that. 17 over 2, yes, 8.5. Now you see this where it says 2 marks, we ought to show some working. Question 12. A code has 5 different digits written in order, starting with the smallest. The last digit is the only square number. The middle digit is the only even number. Work out the code. If the middle digit is the only even number, the square number can't be even because the middle digit is even. So the square number's got to be odd. So it's an odd times an odd. It could be 9. It could be 25. Let's try 9. So let's say the last one is 9. If you go back in order of 1, 8, 6 has got to go there. 5 different digits written in order. You can't have another even number. That'll be 7 there. This one seems a bit confusing to me. I'm not quite sure why. Last digit is the only square number. Ah, can't have a 4 because that would be a square number. Okay, and so yes, that's fine. 2 would be even, so it can't be that. 1 would be a square number because 1 times 1 is 1. So this is the only way it could work. 3, 5, 6, 7, and 9. Okay, I think that's it. Hope the reasoning worked out. Let's go through the reasoning once more. The code is 5 different digits written in order. I thought straight away it's going to be 1, 2, 3, 4, 5 or something like that, but clearly the difference is they're in order smaller to larger. That's all it means really. Because that's 2 between there, 1 between there, 1 between there, and two between there. So, but anyway, let's have a look. The last digit is the only square number, 9. Middle digit is an even number, 6. Okay, so we've got to put 7 in there, can't put 8. We can't put 4 there, so we put 5. And we can't put 1, and we can't put 2, so we have to put 3. Can't put 1 because it's a square number, can't put 2 because it's an even number. It has to be 3. That's it. Done. Question 13. 4 numbers have a mean of 10. 3 of the numbers are 5, 8, and 9. Work out the other number. Well, this is quite common, they ask this sort of thing. So how do we work out a mean? You add up all the numbers, divide by how many you got. So in this case, it's 5 plus 8 plus 9. And we call the other one x because we don't know what it is at the moment. That's divided by 4. And that equals 10 because that's the mean. Now, if I get rid of this 4 on the bottom by timesing by 4, let's go times 4, and know what we mean. So we end up with 40. So x plus 5 plus 8 plus 9 equals 40. I've times both sides by 4. Got rid of the 4 on the bottom. Now to find out what x is, work out the other number, which is x, which is what they want. We simply say, take all these to the other side, or we minus 5, minus 8, and minus 9. And we do the same to the other side. They disappear from there, and we end up with x. X equals 40 minus 5 minus 8 minus 9. And we can use the calculator if we want, and we will. 18. Yeah, okay. X is 18. Or the other number is. Bit of algebra. They want to make h the subject. Doesn't matter which side of the equation is. We've got an equal sign in the middle. We have to balance it. What we do to one side, we must do to the other. We want to get h on its own. Add 4 to both sides. Add 4. So we get h equals d plus 4. Okay. This one, rearrange p equals w over 3 to make w the subject. We times 3 both sides. Times 3. W equals 3p. A linear sequence begins 2, 5, 8, 11. Work out an expression for the nth term. So this is the first. N equals 1, 2, 3, 4. That's the fourth term there. So that was meant to be n. Okay. Now, the difference, look at the difference between them. 2, 3, 4, 5. There's a 3 difference. So you usually show them like this. 3 each time, arithmetic, because it stays the same. So we know it's going to be 3n. That's how we start our thing. Now what I then like to do is to go back 3 like this. Back. There's a difference of 3 there to the 0 term. So 2 minus a 3 going backwards would take us to minus 1, and that's what goes in here, minus 1. All right, check, and we'll do a check. N equals, we'll pick 4. Okay, when n equals 4, we should get 11. So we go 3 times 4 is 12, minus 1 equals 11. Tick ourselves, and our answer is, work out an expression for the nth term. That is this. Okay, 3n minus 1. Okay. The diagram shows a circle, center 0, and 3 straight lines. Okay. Use one word to describe each shaded region. Choose from the arc, chord, sector, segment, or tangent. Okay, basically A, region A, that is called a segment. You know, there's things like minor segment theory or major segment theory. You just need to know it, I'm afraid. So segment, how can we also chop a piece off? Segment, I just want a segment. And this one, region B, is called a sector, right? Think of it like a slice of cake. I'll have a sector of cake, thanks. Work out 1 over 1, 2 plus 4, 6. These are vectors. If it was on a, you don't need to this, but if it was 1, 2, it's a bit like going 1 and up 2. There's one vector there. Okay, and they're just additive because the 1 adds to the 4 to get to this point here, and the 2, which is up there, adds to the 6 to get up here. Not my best drawing, but you get the idea. So we end up with that equals 1 plus 4 is 5, and the 2 and the 6 is 8. Okay, that would be the x component, this is the y component, and they're shown like this to show they're a vector, not a point. Bag A and bag B contain counters. Bag A's got a quarter red, the rest are blue. Bag B, 3 are white, 2 are green. Complete the tree diagram. Well, they've done the red for us, that's a quarter. Okay. So what is blue? Well, this is a bag with red and blue counters. You put the hand in, take out a red, you're going to get a quarter chance. The rest of them are blue. You're not going to take out anything else. So it must be the rest of them, which is going to be 3/4. Because these must add up to 1. Certainty. It's either red or blue. This one, it can be a bit tricky. Remember, you've got 3 are white, 2 are green. You've got a total of 5 in there. So it's out. So the white ones are 3/5, and the greens are going to be 2/5 of a chance. Okay. So let's put those in. White are 3/5. This one is 2/5. Green, yeah, and then 3/5 again, and 2/5. What's the question? One counter is taken at random from each bag. Work out the probability that one is red and one is right. So one counter for each bag, you go red, then white. Okay, not blue, then white, red, then white. So your chances are, and you multiply these now, 1/4 times 3/5. That equals 1 times 3 is 3. This is how we multiply fractions. 4 5s are 20, and it's not going to cancel down. So because I've done it up there, I want to get my 2 marks, show it like that, and put in 3/20. Okay, we've got this triangle, 24 degrees there, it's a right angle. Hypotenuse is 31. This one here, which is opposite, the x is opposite that angle. We have to use trigonometry to work out the value of x. So it's 3 marks. So I think you're going to get a mark just for going saw, ca, toa. All right. And we've got, this is the opposite. Because it's opposite this angle. Right. So we've got the opposite. There it is. And we've got the hypotenuse. We've got h. So we're going to use, we have to use something with both of them in. We're going to use this one. Because there's the opposite. There's the hypotenuse. You can't use this. We don't have the adjacent, which is this bottom one, or the adjacent for that one there. Okay. Now we write down our formula. Sine 24 degrees equals the, I'll just put op down like that, over hypotenuse. So 31. Put h for now, and then I'll go like this. Is it over 31? Okay, we need to get opposite on its own. So we're going to times both sides by 31. Times 31 like that. So we end up with 31 sine 24 degrees equals the opposite. And we do this on the calculator. So the way we do this, 31. You don't need the times sign, you just go sine 24. I close the bracket just for neatness. It probably doesn't matter on this one. What do we get? 12.6. Right, I'm going to go 12.60. I'll go to 4 places. That'll do. All right. Yeah. And it looks about right. It would be about that for that sort of angle. The mass of an iceberg is 2,200,000 kilograms. This value is a 12% reduction from the original mass of the iceberg. Work out the original mass of the iceberg. Give your answer in standard form. Now this is a funny one. The value is a 12% reduction from the original. The original represents the 100%. You got to be careful. So you have to say that this represents 100 minus the 12. So the way I like to do this, you go 2, 2, divided by, and by dividing by 88, we're going to find 1%. And then we times it by the 100 to get our original value, original mass. But you can put it in like this, 100, rather than work out the 88, you can just go 100 minus the 12. Okay. And then times that by 100. It's 3 marks, so we should be able to put the whole thing in, and it'll probably give us the answer in a standard form anyway. 220000. Make sure you get your O's right. Open a bracket. I'm going to put the whole thing in like this. 100 minus the 12. Oops. Minus the 12, Stephen. Move that up to the other side like that. Times it by 100. Right, the answer is 2, 5, get all our noughts right. 2.5 million basically. And they want the answer in standard form. So the way you work out standard form, the decimal point is there, and this is where I like to do it. Count back 1, 2, 3, 4, 5, 6 until you get a number between 1 and 10. It can never get to 10. The most it can be is 9.909 something, but it's got to be 1 or above. So we go 2.5 times 10, and we moved it 6 places. 1, 2, 3, 4, 5, 6. 10 to the 6, because 10 to the 6 is a million, and it's 2.5 million. Okay. A chef has a tub of blueberries. She wants to use all the blueberries. Put the same number of blueberries on each dessert. We got D equals K over B. D is the number of desserts. B is the number of blueberries on each dessert. She wants to use them all. All right. In a quick look at this, it looks a bit complicated, but I think it's straightforward. Let's have a look. What does the constant K represent? Tick the correct box. The number of blueberries in the tub. The number of desserts. Well, no, there's D's the number of desserts. The number of blueberries on each dessert. No, B is the number of blueberries on each dessert. None of the above. Well, I actually think it's the number of blueberries in the tub. Got to tick it. But a way of thinking about this, say the tub had 20 blueberries in it. All right. And B was and you had to use four blueberries on each one. You'd end up with 5 desserts, wouldn't you? Okay, so that works. Maybe you don't need to show that, but that's my reasoning. B is 2, and it makes 120 desserts. So using the thing we just talked about, we can find out how many are in the tub. If makes 120 and B is 2, if I took the 2 up there, 2 times 120, I get 240. So I'm gonna write straight away K equals 240. Okay, because it's twice 120. That's how many are in the tub. So now we can say for this one, if you're going to put 6 blueberries on, you go 6 divided into 24. 6 into 24 is 4. You can get 40 desserts. That's right. And then the other way around, if you've got 30 desserts, you divide 30 into 240. Well, 3's into 24 is 8. 22A, a fair spinner has 6 equal sections, each with the number 5, 6, 7, or 8. Each number appears at least once, right? At least once. So it could be more. So the probability of an even number is the same as the probability of a 7. Well, we've got a 7 there. Got a 7. And you've got 2 even. So for it to be the same as the even numbers, you'd need another 7. Okay, 5, 6, 7, 8, or so you can't have another 7, and you can't have another even. to make up the 6. I mean, you've got something, right? The other one must be a 5. So you've got a 5. Okay, 3 marks. So you're going to use a blank spinner to help us. So let's put them in 5, 6, 2 7s, an 8, and a 5. Yeah, it's 3 marks. I think identifying the 7 and identifying the 5. But if you really want to be pedantic, you can say 2 evens. So 2 7s. Yeah. All right. And the question is, work out the probability of a 5 coming up. We got 2 5s. Yeah. That's 2 out of 6, wasn't it? 2 out of 6, which equals 1/3. Okay. Chance of getting a 5 is 1/3. A different spinner has 10 sections, each labelled A, B, C, or D. Give one reason why there must be a mistake in the table. Whenever you see these are nearly always that it doesn't add up to 1. Right, it's got 10 sections. They're all labelled A, B, C, or D. They could, D or C, they may be labelled more than once, but these are supposed to be the probabilities of them. If we add them, 0.1, 0.5, 0.2, and 0.3, that should be all of it. So 3, 4, 5, and 5 is 10, and 1 is 1.1. Well, it's 1.1. 1.9. Not 1. Make it into a 1. Here is a sketch of the graph y equals minus 2x plus 6. So the slope's going down, which is the minus 2 bit. Plus 6. Well, 6 is going to be where the intercept is, crossing the y there. So that we can put that in as 6. Complete the coordinates. 0, 6. And D, where's this one? Well, that's a bit strange. The easiest way to put that in, that's when y, if you think coming up the y is 0. So think of this as 0. So let's put it in. 0 equals minus 2x, which we don't know yet, plus 6. Take the minus 6 from both sides. So we end up with minus 6 equals minus 2x. And then you divide by minus 2. Minus 2, because the minus 2 is multiplying this x. So we do the same on that side. Minus 2. Right, it's a minus divided by a minus, so it's going to be a positive, and it's 6 divided by 2, which is 3. I mean, we could get that by just looking at the slope, because it's a 2. If that was 6, this has got to be 3, but that's how I would do it. 23b. Here is a sketch of a quadratic graph. Complete the following statements. The value of the y-intercept, well, that's only where it crosses the y, and they've told us there is 5. That's 1 mark. The x-coordinate of the turning point when it's going up and then coming down. So that is this point here, t. And they tell us it's t anyway. And that always, because it's symmetrical, it's got to be halfway between minus 2 and 8. And an easy way to do it is you average it. Minus 2 plus 8 divided by 2. So minus 2 plus 8 is positive 6. Divided by 2 is 3. Yep. Archie flips a bias coin 200 times. Here is some information about the outcomes after each 50 flips. 50 managed to get 10, 100 he got 27, 150 got 37, and 200 he got 52. Work out the best estimate for the probability of flipping ahead. Give a reason for your answer. Well, you would always pick the most number of flips of the coin, because that's the greatest data. You know, lower down, we're open to more chance. The more flips we got, the less it's down to just chance. Well, it's all chance in a way, but you know what I mean. Right, okay, so we write that as 52. It came up 52 times out of 200. We can cancel this down. by dividing it by 2. Yeah, 2's into 52 is 26 over 100. I'm not sure, they don't say we have to cancel it down, which is 13 over 50. Why am I doing that? Because we can use the calculator. I can go 52 over 200. There we are, 13 over 50. And the reason is 200 is a bit overkill, I expect, but you get the idea. A lion is sprinting in a straight line away from his den. Okay. The graph shows the lion's distance from the den. I was wondering why he wasn't going for 0, because you'd think he was, but he may have been just a little way away from the den in the first place. Work out the speed of the lion in meters per second. Oh, okay, meters per second. Well, he's starting here at, this is 25. I think it's going up in 5, 5, 10, 15, 20, 20, yes, to 50. So this point here is 30. 30. And this point here is 120. Okay. So in 5 seconds, so first of all, what I do about speed, if you're not sure about speed, it tells you meters per second. Per means divide. So it means the meters, which is the distance he's run, so it's 120 minus 30 divided by the number of seconds. So it took him to run that distance, it took him 5 seconds. And it's in seconds, it's in meters. They want the answer in meters per second. So I can just work that out as, and I can use the calculator just like that. 120 minus the 30 over the 5. 18. I suppose that's quite fast, isn't it, for a lion? 18 is our answer. I'll put that further down. 18 meters per second. And there is the end of our questions. Well, I hope you enjoyed it and found it useful. And as I mentioned, I'll put the link to my book in the description below. Thank you very much for watching. See you in the next one. Bye.